So today we are going to cover normal form. See, my aim is to cover normal forms. Now let us see the problem of determining in a finite number of steps whether a given statement is a tautology or a contradiction or at least satisfiable is known as a decision problem. And obviously, the construction of truth tables involves a finite number of steps, and after finite number of steps we are able to determine whether the given statement is a tautology or contradiction or at least satisfiable. So here we are sure and it is obvious that after finite number of steps we will be able to know whether the problem is a tautology or contradiction or at least satisfiable. But as the difficulty of the problems increases, it is not possible and even it is not practical to decide whether the given statement is a tautology or contradiction or at least satisfiable. So the alternative way is to reduce it to normal form. And basically, if we see, the normal form is of two categories. The first one we will call disjunctive normal form. See here, first one is disjunctive normal form, and the second one is conjunctive normal form. So first of all, we will try to understand what is disjunctive normal form and what is conjunctive normal form, and later on we will see what is its role in order to decide whether the given statement is a tautology or a contradiction or at least satisfiable. So first of all, see, we define the elementary product and elementary sum. First I define elementary product, and elementary sum. See, when we say elementary product, so what is extra apart from the product? The extra thing is that we are considering product of the variables and their negation. So when I use this word elementary along with the product, then it means product of variables, we mean product of the variables, and their negation. Similarly, if I say elementary sum, sum, then it means the sum of the variables and their negation. What I mean? Sum of the variables and their negation. So let us try to understand. Suppose I take the two variables uh, P and Q. Let us take the two variables P and Q. These are atomic variables. These are atomic variables. Then when I say elementary product, when I say elementary product, what it involves? It involves first the atomic variables itself, P and Q, and product. Product means the meet of the variables or their negation. So I may have here in this category P meet Q, P meet not Q, then not P meet Q, not P meet not Q, and I can also extend it. For example, I can go with P meet Q meet not Q, and we can continue in this manner. So what are these? These are elementary product. These are elementary product. And similarly, when we go for the sum, then the meet here can be replaced by the join symbol. So again, I consider PQ as my atomic variables. I consider PQ as my atomic variables, and then I can have the atomic variables itself, PQ, and the join of the variables or their negation. So I can have P join Q, P join not Q, and not P join Q, and not P join not Q. Also I can extend it to 3, 4 or more other expressions. For example, I can go for P meet not P, it should be join. So P join not P join Q, and in this way I can go for. So what are these? See, these are elementary sum. These are elementary sum. So once I know what we mean by elementary product and elementary sum, I can go for the first question, and that is, what is disjunctive normal form and what is conjunctive normal form? So first of all, I will go for the disjunctive normal form. So when I go for disjunctive normal form, I am talking about a logical expression which is a sum of elementary product. So I can write here in shortly, a logical expression which is a sum of which is a sum of elementary products. And when I am talking about conjunctive normal form, then I am talking about a logical expression which is the product of, or you can say conjunction of, or I say the product of the elementary sum. The product of the elementary sum. So product means, here what I say mean product means meet, or what here we mean by sum means join. I say here join, right? So once we have this, we will try to understand what are the steps involved in converting a logical expression into CNF. So first of all, see, here we have only 3 steps and we have to follow these 3 steps with clear view in mind that which symbols we will use and how to treat negation and when it is absolutely not needed and when it is needed, and how to apply distributive law. So see, the steps basically involve 3 steps. So number 1 is removing I say here conditional and biconditional. Biconditional is this one, using the expressions which involve meet, join, meet, join and negation. Meet, join and negation. So meet, join and negation. So see how I can go for. Suppose I have one expressions like alpha implies beta, right? We are using conditional. Here we have the statement alpha implies beta. So this is equivalent to not alpha join beta, right? The first thing. So this is followed in both conversion. Either we are going for CNF or we are going to convert our expression in DNF. And next is suppose I have biconditional. So if I have expressions like this, alpha if and only if beta, we have biconditional. Then we have 2 expressions, one for CNF conversion and one for DNF conversion, right? So see, for CNF conversion, which formula I will use? See, for CNF conversion, I can go for alpha implies beta, meet beta implies alpha. And see, the first one, alpha implies beta, I can use this first one. So using this first one, I can say not of alpha, join beta, meet. And second one, beta implies alpha, again I will go for the first one and I will swap the role of alpha and beta, and I can say here minus not of beta join alpha. So this step I will use for CNF conversion. See here, this I will follow for converting to CNF. This should be remembered because CNF means conjunction. Conjunction means meet. See here, I have meet conjunction, that is product of elementary sums. Yeah, right? You can see it is conjunction of elementary sum. But we have another expression also which we are going to use for conversion in DNF, and that is, see, when I am saying alpha if and only if beta, then this is equivalent to alpha meet beta and join not alpha meet not beta. And this is we are using while converting my expressions into DNF. This is when I am going to convert my expressions into DNF. So this is the first step, and we must be very much clear when to use the formula for biconditional when we are required to convert it in the forms which contains meet, join and negation. For conversion into CNF, I am going to use the second formula which is written in red color, and for conversion into DNF, I am going to use last formula which is written in blue color. And now the second one, we have to be very much careful when I am going to use the second step. And the second step is to remove negation. So second step is removing negation using De Morgan's law. Removing negation using De Morgan's law. And here is also one crucial thing, negation where negation should be before compound statement. Negation before compound statements. Compound statements, right? See, if we are capturing negation before primitive, so negation before primitive should not be touched. So I write here that negation before primitive statement, before primitive should not be touched, should not be touched, or you can see it should not be handled. We will not apply De Morgan's law. What is De Morgan's law here? See, De Morgan's law means negation of the join of two primitive statements and negation of the meet of two primitive statements. So what is this? See here, negation applies to separately each of the atomic statements, and meet and join will swap. So what happens? Here you can see negation applies, this negation applies to alpha as well as beta, right? So negation of alpha and join here will become meet and negation of beta. In the same way, the second statement, negation of alpha, meet will become join, negation of beta. So these are the De Morgan's law, and one thing which is very much crucial here, and that is negation before compound statement should be handled, not before the primitive statement. And I have the final step. The final step is we should apply distributive law till we get the desired form. So I say apply distributive law, till we get the desired form. Right? So these are the only 3 steps, and I have covered entirely all the things which is necessary to convert into DNF or to convert into CNF. So let us try to solve some problem and see how we can handle problems. And once we try to learn these 3 steps, then it becomes easier to determine whether the given statement is a tautology or contradiction or satisfiable. So number 1, I am going for the DNF conversion. So let us take the problem. Question is determine the DNF of the following forms. Determine the DNF of the following forms. So you can see here the first question is P implies Q, and I have this implies P, right? So see here, I will apply the first step. First step is to handle conditional or biconditional. Here only conditional is appearing. So first conditional is here, again next conditional is here. So first of all, look, if I handle here, then if I use the formula, you can see alpha implies beta is equivalent to negation of alpha implies join beta. So I am using this formula. So it is negation of P join Q, and this implies P. Again I go for handling the next conditional here. So this is equivalent to negation of P join Q, and I go for its negation because this is hypothesis and I have to go for the negation of hypothesis. So here hypothesis is this much, this whole is my hypothesis. I have gone for the negation of whole, then join. So I have join symbol next. and then beta. Beta is what? Consequent, which part is appearing after conditional symbol, and after conditional symbol here is P, so I will write here P. So this is done. So once conditional is handled, I will go for distributive law in order De Morgan's law in order to handle negation. So here you should check that here negation is appearing. See, I am highlighting the part negation is appearing before primitive statement, but I will not touch this. So where I will put efforts, I will put my effort to handle this. And this is purely done by De Morgan's law. So I apply De Morgan's law and see negation. So negation of P, join, it will become meet, and negation of Q, and here is join P. I go with this, and I know negation of negation is itself, so it is P meet not Q, join P, right? So what you can see here, it should be the join of elementary products. To see the part which is coming before and after join symbols are elementary products, and we have the join, so it is in the required DNF form. So this is my complete reduction, and we have done. I got my answer, right? Similarly, I will solve some more problems. Let us see the another one. I will go for the next question. Suppose I have another question. Let us see how we can handle it. P implies, then I have Q implies P. P implies Q implies P. So first of all, I will handle this conditional. See here, I write P implies. Here I have not Q join P. I have used the alternate expression. See which expressions I have used. I am writing it with say this one. Which expressions I have used? Alpha implies beta is equivalent to not of alpha join beta, right? I have used here, and again I will go for conversion of this conditional. So again what I am going to get, let us see. Here P is there, so negation of P, join the next statement, negation of Q join P. Negation of P join negation of Q join P. So now you can again go for and look what I am going to get. See here, I have negation of P join negation of Q and join here, right? And what about this one? Negation of P and negation of P is there. So if I take its join and I go for its join with negation of Q, so I am leaving my expressions with this one only. Negation of P join P only. Negation of Q will disappear. So you can see here again I have uh, the required conversion. I have gone for the required conversion in DNF. Let us go for one more problem in order to understand the concept clearly. So I go for the question number, say C. See here, I have the question P implies Q. P implies Q meet, not P meet Q. Right? I have this one. So first thing which I have to handle is what? Conditional. So conditional is appearing here. So it is not of P join Q, and here I have meet, not P meet Q. Right? Not P meet Q. Again, the thing is over, but if you look for the second step, negation is appearing in two places. One here you can see, and you can see next here, but it is before primitive statements only, so we are not going to do anything. It should be before compound statements. It is not so, so I am not going to use the second step, although I am going to use the third step. So this is the place where I am going to use distributive law. So distributive law, you can see if I apply, then I am going to use, see here, this whole part will come here, and it also go along with Q, right? So what I am going to get, see, negation of P meet, and this whole thing, negation of P meet Q, negation of P meet Q, right? Negation of P meet Q, and then I have join symbol, then I have Q meet, negation of P meet Q. So one step is only left, and that is negation of P meet negation of P. So this will become negation of P only meet Q, and then I have join Q meet. Here Q and Q is there. I apply commutative law, and then Q meet Q will be there, and Q meet Q is Q, and I write its meet with negation of P, and this is the required form. This is the required form, right? So again, we can go further and we can decide how we can convert into CNF. So the next question which we are going to do is determine the CNF of the following forms. Determine the CNF, conjunctive normal form, of the following forms. So let us do some problems, and once we do some problems we will try to understand. Number one, P implies Q implies P implies Q implies P, and I have to go for. So first of all, again I can see two conditionals are there. First I handle this conditional, next I will handle the next one. So when I handle negation of P join Q, as I have already explained, and it's a conditional. Again, the second conditional, if I will handle, then negation of hypothesis, that is negation of P join Q join hypothesis consequent is P, consequent is this part, and now it is the place where I can use De Morgan's law. See, negation is there, so negation applies to each of the atomic statement here, and here join will become meet. So negation of P, negation of P is P, join will become meet, negation of Q, and then I have join P. So it is this part is going to be distributed. So I will have P join P, meet, not Q join P. So it is distributed, and I have the required conversion. I have the required conversion here. You can see it's easier. I can again solve the next question. The next question is, see here, P implies Q implies P. So again I go with similar steps. P implies negation of Q join P, and again I have one more negation conditional. So hypothesis is P and consequent is negation of Q join P. So hypothesis, its negation should be taken, negation of P, conditional becomes join, and next part will remain as it is, right? And again I can see here, and because everywhere is join, it is negation of P join negation of Q join P, and you can see here what will remain in the picture. The things which remain in the picture is P join negation of P, right? So this is the way by which I can handle. And suppose I am going to take one more problem in order to understand biconditional. I can go for one more question in order to handle biconditional. So biconditional has two forms. Which one we have to use, that I have already discussed. So that should be taken care of. Suppose negation of P implies R, and I have meet of this expression with P if and only if Q. P if and only if Q. So just have a look what I can do here. I have to use conditional, I have to use biconditional conversion. So see, this one I can use negation of P, hypothesis is negation of P, so its negation is P join R. So okay, I am going with very good form, meet, and if I have P if and only if Q. So here conversion is in CNF. See, conversion is in CNF. So which formula I am going to use, that should be given extra care. See, for CNF, you can see here, for CNF I am going to use this formula. So here negation of alpha join beta, meet negation of beta join alpha. I am going to use this one, and with this it is negation of P join Q, right? Negation of P join Q, meet negation of Q join P. Meet negation of Q join P. So you can see you have got the required conversion. So this is the complete thing, complete package by which I am going to convert CNF into DNF and DNF into CNF or any other expressions into CNF into DNF. So these are the steps which should be followed, and the final thing which is left is how we can say the given statement is a tautology or contradiction or at least satisfiable. So for this there is two additional part which I am going to express here, and that is an elementary sum and elementary sum is identically true, is identically true if and only if and only if it contains at least one pair it contains at least one pair of factors, in which one is the negation of other, in which one is the negation of other. And similarly, an elementary product is identically false. An elementary product is identically false if and only if it contains at least one pair of factors, it contains at least one pair of factors in which one is the negation of other, in which one is the negation of the other. So this is all about normal forms. Thank you.